Math Dominators! Welcome back to another session of Math 8 live streaming lesson. I am Ma'am Wendy Raimundo, your math buddy for today. I am here to guide you in learning the different concepts and skills in mathematics. Is your self-learning module ready? What about your pen and paper? Great! Now let's begin a fun and exciting lesson. Our discussion today will center on applying or simply the application of theorems on triangle inequalities. And we are now on the fourth quarter, week 2, which means that we only have few weeks remaining before the end of the school year. Yes, you heard me right. So be sure to catch up and comply all the requirements given by your teachers. For this lesson, you are expected to apply theorems on triangle inequalities. Let's get started. How about some warm-up exercises? Are you familiar with these three main characters from the movie entitled Frozen? I'm sure you do. These three main characters have something to do with our activity for today. Elsa, help us out. Our friend Olaf is missing. Please help us by answering the riddles as fast as you can. Anna, don't worry, Elsa. We can find Olaf. The students will help us. So my dear students, let us help Elsa and Anna to find Olaf. Just simply type in your answer in the comment section. And these are the possible answers for our riddles. Door, closet, laptop, book, refrigerator, and gate. For our riddle number 1. You can see me almost everywhere, at almost every place. You can turn me around and push me, but you'll never see my face. You can hold me tight and release me, but you'll never see me fall. You can lock me up or set me free, but I never leave at all. What am I? For those who type door as their answer, then you are correct. Do you know that when you open a door, it will form a triangle? Yes, just like this. Let us recall the triangle inequality theorem number 1, or side angle inequality theorem. If one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Using the triangle that formed from opening a door, we have triangle SAN or triangle SUN, which the length of the side UN is 15 and side SN is 13. Based on the length of the sides, 15 is greater than 13 or side UN is greater than the side SN. Therefore, the measure of angle S, which is the opposite of the larger side, is greater than the measure of angle U, the opposite of the smaller side. Riddle number 2. I have shelves, but I'm not a bookcase. I have a door, but I'm not a cupboard. I have a light, but I'm not a lamp. I contain food, but I'm not a grocery store. What am I? You are absolutely correct if your answer is refrigerator. Just like a door, when you open a refrigerator, it will form a triangle as well. Now let us recall the triangle inequality theorem number 2, or angle side inequality theorem. If one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. The triangle that formed from opening a refrigerator is triangle BTS. The measure of angle T is 105 and the measure of angle B is 30. From the given triangle, the measure of angle T is greater than the measure of angle B. Therefore, side BS, the opposite side of the larger angle, is greater than the side TS, the opposite of the smaller angle. This time, let us recall the exterior angle inequality theorem. The measure of exterior angle of a triangle is greater than the measure of either remote interior angle. An exterior angle of a triangle is an angle that forms a linear pair with one of the angles of the triangles, while the remote interior angles are the interior angles of a triangle that are not adjacent to a given exterior angle. Using the same triangle, let us identify the remote interior angles and the exterior angle. The remote interior angles are angle B and angle T, while the exterior angle is angle TSM or angle MST. Applying the exterior angle inequality theorem, the measure of angle TSM is greater than the measure of angle T, and the measure of angle TSM is greater than the measure of angle T. Riddle number 3. I'm something that's been written. Although I'm not a song, I can be a short story or novel that is long. What am I? The answer is book. When we open a book, it will also form a triangle, just like this. Recalling the triangle inequality theorem number 3, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. In symbol, let's have the sides of a triangle as A, B, and C. So we have A plus B is greater than C. B plus C is greater than A. And A plus C is greater than B. From the given triangle that have the sides A, B, and C, let's use A plus B is greater than C. So when we add the sides A plus B, it is greater than C. Now let's have B plus C is greater than A. When we add the two sides of B and C, it is greater than A. And the last is A plus C is greater than B. When we add the sides A and C, it is greater than B. Riddle number 4. Don't be late, as here I will wait. What do you think am I? The answer is gate. Let us recall the hinge theorem or the SAS triangle inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite to the larger included angle. Do you know that a gate like this can form two triangles? Yes. And the length of the third side of a triangle will be based on how you widely open the gate. Triangles are named as Bea and Joule. The measure of angle B is 45 and the measure of angle J is 30. Since the measure of angle B is greater than the measure of angle J, therefore, side EA is greater than the side UL. And for our last riddle, I have a door, but I'm not a car. I have things hanging inside me, but I'm not a gallery. I contain clothes, but I'm not a washing machine. The correct answer is closet. Same also with the gate. When you open a closet like this, it will also form a triangle. Now let us recall the converse of the hinge theorem or the SSS triangle inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, and third sides are not congruent, then the larger included angle is opposite to the longer third side. The triangles are named as Ger and Ald. Based from the given triangles, side ER is greater than side LA. Therefore, the measure of angle G is greater than the measure of angle D. That's it, students. Thank you for helping Anna and Elsa by answering the riddles as fast as you can. Now, they already found Olaf because of your help. I hope you enjoyed our activity. Now, let us proceed to our main discussion, which is the application of theorems on triangle inequality. The first theorem is triangle inequality or side angle inequality theorem. It stated that if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. Let's have example. List the angles of triangle ABC from the smallest to largest. Given, AB is equal to 17, the side BC is equal to 21, and AC is 18. So to find for the smallest to largest angles, we need to look on the smallest to largest side as well. And the smallest side of the triangle ABC is side AB. The opposite angle of side AB is angle C. Then, second side which is larger than the side AB is side AC. And the opposite angle of side AC is angle B. The largest side is BC, and the opposite angle of side BC is angle A. Therefore, the smallest to largest angles are angle C, angle B, and angle A. Example number 2. Solve for the value of x if the perimeter of the triangle is 27 cm. Find the measurement of side TW, WO, and TO. Arrange the angles from least to greatest. Do you still remember the formula of the perimeter of a triangle? If you do, kindly comment your answer. The formula is P is equal to A plus B plus C. The perimeter of a triangle is the sum of all its three sides. Using the formula, we have P is equal to A plus B plus C. Then substitute. The perimeter is 27 equals x plus 3 plus 2x. Then combine like terms. We have 27 is equal to x plus 2x plus 3. So 27 is equal to x plus 2x is 4x plus 3. Applying SPE or subtraction property of equality, we need to subtract both sides by 3. So 27 minus 3 is equal to 4x plus 3 minus 3. And 27 minus 3 is 24 equals 4x. In order to solve for x, we need to divide both sides by 4. So 24 over 4 is equal to 4x over 4. And 24 divided by 4 is 6 equals 4x divided by 4 is x. Applying the symmetric property, it can be rewritten as x is equal to 6. Now let us find the measurements of TW, WO, and TO. The TW is equal to x. So TW is equal to 6 centimeter. Next is the side WO is equal to x plus 3. WO is equal to 6, the value of x plus 3. So WO is equal to 9 centimeter. TO is equal to 2 times the value of x, which is 6. So TO is equal to 2 times 6 is 12 centimeter. The last thing to do is to arrange the angles from least to greatest. The angles of the triangle TW from least to greatest are angle O, the opposite of the least side. Next is angle T, which is the opposite of the greater side. And the greatest angle, which is angle W, the opposite of the greatest side. Next theorem is the triangle inequality theorem number 2, or angle side inequality theorem. If one angle of a triangle is larger than a second angle, then the side opposite the first angle is longer than the side opposite the second angle. Example number 3. Name the longest and shortest side of triangle XYZ. Given, measure of angle X is equal to 46 and measure of angle Y is 30. In order to name the longest and shortest, we need to solve for the another angle of a triangle XYZ, which is the angle Z. We have measure of angle X plus measure of angle Y plus measure of angle Z is equal to 180 degrees, which is the sum of the interior angles of a triangle. Now let's substitute. The measure of angle X is 46 plus the measure of angle Y is 30 plus measure of angle Z is equal to 180. 46 plus 30 is 76 plus measure of angle Z is equal to 180. Now, we will subtract both sides by 76. That is by using the SPE or subtraction property of equality. So we have 76 minus 76 plus measure of angle Z is equal to 180 minus 76. So measure of angle Z is equal to 180 minus 76 and the measure of angle Z is 104. The largest angle is angle Z. Therefore, the longest side is XY. And the smallest angle is angle Y. Therefore, the shortest side is XZ. Example number 4. Find the value of X and list the sides of triangle HOT from shortest to longest. To solve for X, we will use the sum of the interior angles of a triangle. Measure of angle H plus measure of angle O plus measure of angle T is equal to 180. Then substitute. The measure of angle H is 10x plus the measure of angle O is 7x minus 1 plus the measure of angle T is 5x minus 17 is equal to 180. Then combine like terms. 10x plus 7x plus 5x minus 1 minus 17 is equal to 180. We have 22x minus 18 is equal to 180. In order to solve for x, we need to add both sides by 18, and that is by using the addition property of equality. So 22x minus 18 plus 18 is equal to 180 plus 18. So 22x is equal to 198. To solve for x, we will use the division property of equality. We will divide both sides by 22. So 22x over 22 is equal to 198 all over 22. 22x divided by 22 is x is equal to 198 divided by 22 is 9. So the value of x is 9. This time, we will solve the measure of the angles. So measure of angle H is equal to 10x. measure of angle H is equal to 10 times the quantity of 9, which is the value of x, and the measure of angle H is equal to 90, because 10 times 9 is 90. Next is measure of angle O is equal to 7x minus 1. So measure of angle O is equal to 7 times 9, the value of x, minus 1. So measure of angle O is equal to 7 times 9 is 63 minus 1. And measure of angle O is equal to 62. Last angle is measure of angle T is equal to 5x minus 17. So measure of angle T is equal to 5 times 9, the value of x, minus 17. So measure of angle T is equal to 5 times 9 is 45 minus 17. So the measure of angle T is equal to 28. So measure of angle H is 90, measure of angle O is 62, and measure of angle T is 28. So the shortest to longest sides are the side HO, HT, and the side TO. Next is the triangle inequality theorem number 3. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. In symbol, let's have the sides of a triangle as A, B, and C. So A plus B is greater than C, B plus C is greater than A, and A plus C is greater than B. To begin with this theorem, allow me to introduce first the compound inequality. It is written as compound inequality that shows the possible values for the third side of a triangle when given only two lengths. Let the value of the third side of a triangle, then the range for the third can be solved using the compound inequality. X is greater than the difference of the two sides but less than the sum of the two sides. Let's have an example. If two sides of a triangle have measures 9 inches and 15 inches, between what two numbers must the third side fall? Using the compound inequality, we have x, which is the greater than the difference of the two sides, which is 15 minus 9, but less than the sum of the two sides, which is 15 plus 9. So 15 minus 9 is 6, and 15 plus 9 is 24. So the range would be x is greater than 6, but less than 24 inches. Therefore, the third side of the given triangle must lie between 6 inches and 24 inches exclusive. Let's have another example. Given triangle BEH, find the largest possible integral value of the side BE if BH is equal to 12 and EH is equal to 7 cm. Side BE is greater than the difference of the side of the two sides, 12 minus 7, and less than the sum of the two sides, 12 plus 7. So 12 minus 7 is 5, and 12 plus 7 is 19. So we have side BE is greater than 5 cm and less than 19 cm. Therefore, the largest possible integral value is 18 cm. Now let us proceed to the exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Example number 7. In the figure below, identify the angle or angles that is or are less than angle 4. The angles that are less than angle 4 are its remote angles. The remote angles are angle 1 and angle 2. By applying the theorem, measure of angle 1 is less than measure of angle 4, and measure of angle 2 is less than measure of angle 4. Therefore, the angles less than angle 4 are angle 1 and angle 2. Example number 8. Identify the angle or angles that is or are less than angle 7. By using this triangle, we can easily identify the remote angles of angle 7. They are angle 1 and angle 2. And the other remote interior angles are angle 4 and angle 5. Applying the theorem, measure of angle 1 is less than measure of angle 7. Measure of angle 2 is less than measure of angle 7. Measure of angle 4 is less than measure of angle 7. And measure of angle 5 is less than measure of angle 7. Therefore, the angles that are less than angle 7 are angle 1, angle 2, angle 4, and angle 5. The next theorem that we will talk about is the hinge theorem, or the SAS or SAS triangle inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite to the larger included angle. Example number 9. The diagram below shows a pair of scissors in two different positions. In which position is the distance between the tips of the blades greater? Since the angle on diagram 1, which is 62 degrees, is less than the angle on diagram 2, which is 93 degrees, by hinge theorem, we can say that the tips of the blades on diagram 2 has a greater distance in comparison to diagram 1. Next example. Find the range of the possible values of x. In triangle PAK or PAK and triangle RAK, side PA is congruent to side RA. And by the reflexive property of congruence, side KA is congruent to the side KA. Since measure of angle RAK is less than measure of angle PAK, then RK is less than PK. Using compound inequality, we have RK is greater than 0 but less than PK. The measure of RK must be greater than 0 but less than the value of PK, which is 60 units. By substitution, we have 5x minus 10 is greater than 0 but less than 60. Applying the addition property of inequality, we will add both sides by 10. So 5x minus 10 plus 10 is greater than 0 plus 10 but less than 60 plus 10. Simplifying, we have 5x is greater than 10 but less than 70. To solve for x, we will apply the division property of inequality. We will divide both sides by 5. We have 5x over 5 is greater than 10 over 5 but less than 70 all over 5. And x is greater than 2 but less than 14. The last theorem is the converse of the hinge theorem, or the SSS triangle inequality theorem. If two sides of one triangle are congruent to two sides of another triangle, and third sides are not congruent, then the larger included angle is opposite to the longer side. Last example, find the set of possible values of x. In triangle NOM and triangle BER, the side NM is congruent to the side BE, and the side MU is congruent to the side RE. Since BR is less than MU, then the measure of angle E is less than measure of angle M. Using compound inequality, we have measure of angle M is greater than measure of angle E but less than 180. The measure of angle M must be greater than the measure of angle E, which is 72 degrees, but less than the total value of the angles of a triangle which is 180 degrees. Substitute 6x minus 12 is greater than 2 but less than 180. Applying the addition property of inequality, we have 6x minus 12 plus 12 is greater than 72 plus 12 but less than 180 plus 12. Simplify. 6x is greater than 72 plus 12 is 84 but less than 180 plus 12 is 192. In order to solve for x, we will apply the division property of inequality. So we will divide both sides by 6. We have 6x over 6 is greater than 84 over 6 but less than 102 over 6. And 6x over 6 is x is greater than 84 over 6 is 14 but less than 192 over 6 is 32. Our answer in interval notation is open parenthesis 14, 32, or in set builder notation we have x such that x is greater than 14 but less than 32. Now, let us check what you have learned from our discussion. But before proceeding, let me share one of my favorite sayings I hold into as a mathematics teacher and a learner at the same time. God's plan is always greater than our plans. And now, let's proceed to our activity entitled Complete Me. Compare the following figure using less than, greater than, or equal. And you have 10 seconds to answer each number. Number 1. Side AT is blank to side AD. Comment heart if it is less than, like if it is greater than, and wow if it is equal. And the answer is like. ET is greater than AD. Number 2. Side MO is blank to side RO. And the answer is heart. Side MO is less than side RO. Number 3. Side SE is blank to side LK. And the answer is side SE is less than side LK. Number 4. Side PY is blank to side AR. And the answer is like. PY is greater than AR. Number 5. Side MT is blank to side HM. And the correct answer is love. MT is less than HM. For number 6, What is the value of x given the triangle ABC with the angle A x degree, angle B is 3x degree, and angle C is 2x degree? So type hard if the value of x is 30, like if the value of x is 40, and wow if the value of x is 50. And the value of x is hard, which is 30. Next, number 7. What do you think is the measure of angle A? Is it hard 30, like 60, or wow 90? Since the value of x is 30, therefore the measure of angle A is also 30. Number 8. Measure of angle B. Is it 30, 60, or 90? Comment your answer. The measure of angle B is 90, which is wow. Number 9. Measure of angle C. Comment your answer. The measure of angle C is like 60. And last number. Arrange the sides from longest to shortest. Angle A is 30 degree, angle B is 90 degree, and angle C is 60 degree. Is it hard, like, or wow? The answer is hard. The longest to shortest sides are the side AC, side AB, and the side BC. I hope today's lesson has been very helpful. Now, it's time to entertain the queries that you dropped in our comment section. And for those who haven't typed yet their queries, I will give you 60 seconds to key in your questions in the comment section. And your timer starts now. I'm back. We have here a question from the comment section. Why is it called hinge theorem? The reason why it is called hinge theorem is because it was named after the tool hinge. Since we're running out of time, if you have some queries, kindly raise it to your subject teacher. I am sure they are more than happy to address it. And please do take screenshot of your assignment. So see you again next time as we face and overcome the mathematical challenges ahead.